In this video, we're going to continue our discussion about nuclear chemistry and take a look at the half-life of radioisotopes. So what is a half-life? Half-life is the time required for half of the atoms in any given quantity of a radioisotope to decay. Remember what a radioisotope is. It's basically an isotope that emits radiation because the nucleus is unstable. And what does it mean when a nucleus is unstable? It means that the proton to neutron ratio is too high. Each isotope has its own half-life. So let's take a look at an example. Here's strontium-90. Strontium-90 has a half-life of 29 years. If you had 10 grams of strontium-90 today, 29 years from now, you would have 5 grams left. So if you take a look at this graph, we start at 100% or at 10 grams. In 29 years, this amount gets cut in half as strontium-90 decays. So 10 goes to 5. And it takes another 29 years for 5 grams of strontium-90 to decay to 2.5 grams. 2.5 grams, 29 years later, will go to 1.25. 1.25 will again be cut in half in 29 years. If you look at the percentages, it goes from 100% to 50% to 25% remaining to 12.5% remaining, and so on and so on. Now, will this ever reach zero? No, it will not ever reach zero. So, there will always be traces of a radioisotope that remains in the earth and around us. Here's another way to look at it. Mathematically, we can just keep multiplying by half, and you will see that it goes down, it decreases by half. Here is a formula that you could use. However, I am going to show you a different way without having to plug it into a formula at all. Let's take a look at this example. Iron 59 is used in medicine to diagnose blood circulation disorders. The half-life of iron 59 is 44.5 days. How much of a 2-gram sample will remain after 133.5 days? Let's go ahead and write down some information that it provided for us, okay? So we have the initial amount, we're going to find out the final amount. It gives us the half-life, and it talks about a total time. In fact, when it comes to these practice problems, these are the 4 things that you will always, or that you can always write down. Okay? So the initial amount, we have 2 grams. It says how much will remain, so it's the final amount that we're trying to determine. The half-life is 44.5 days, and the total time is 133.5 days. So the way to go about solving these problems is making like a timeline. So over here on the left side, we have our initial amount. And over here at the end, we have our final amount. We begin with 2 grams. And we're going to go ahead and cut this in half. So half of 2 is 1. Now the time it took for it to go from 2 grams to 1 gram is 44.5 days. We're trying to figure out how much will remain after 133.5 days, so we want to go ahead and go through another half-life. Half of 1 is 0.5 grams. This took another 44.5 days. Right? but the total amount of days that it took is actually 89. So I'm going to go ahead and write the total amount of days that passed by here. So we now have 89.0 days. In another 44.5 days, it's going to go through another half-life. And so we're going to write half of 0.5, which is 0.25 grams. So this took from 0.5 to 0.25, it took another 44.5 days, which is a total of 133.5 days. So how much remains after 133.5 days? It's 0.25 grams that remains. That right there is our final answer. So just to recap, what did we do? On the top, with our initial amount, we divided by 2 each time. On the bottom, when we're talking about time, we added the half-life each time. And this is what we're going to use as we go through the problems today. You'll see that in the other problems, I might be asking for different things, like what was the initial amount, or what is the half-life, or what is the total time. So let's take a look. If gallium has a half-life of 68.3 minutes, how much of a 16 milligram sample will be left after 2 half-lives? So again, I'm just going to go ahead and write the same thing. Initial amount, final amount, half-life, and total time. It says that gallium has a half-life of 68.3 minutes. How much of a 16 milligram sample will be left over after 2 half-lives? So it doesn't give me an actual total time, but it does say that it's going through 2 half-lives, meaning it's going through the half-life twice. Okay? So we're going to go ahead and start from the beginning, 16.0 milligrams, and it goes through 1 half-life, therefore half of 16 is now 8. So I can put 68.3 minutes here, but why bother, because they tell me that it's going through 2 half-lives, so I'm just going to go ahead and just put 1 there because that arrow indicates a half-life. And it's going to go through another one. And so the 8 milligrams goes down to 4 milligrams, and there's our second half-life. So our final answer is 4.0 milligrams. Let's take a look at this one. If the half-life of uranium-235 is 7.04 years, and 12.5 grams of uranium-235 remain after 28.2 years, how much of the radioactive isotope was in the original sample? So again, let's go ahead and fill out the information that's given. And I'm going to go ahead and abbreviate initial amount for IA, final amount FA, half-life HL, and total time TT. Okay? So it says half-life is 7.04 years, and that 12.5 grams remains after 28.2 years. How much was in the original sample? So this time, because they give us the final amount, we're actually going to start at the very end. So 12.5 grams. And we are basically going to work backwards. But to help us out a little bit, let's go ahead and just do a little bit of math here and figure out, well, how many times will it go through the half-life? Well, how are we going to figure that out? If you said total time over the half-life, you are correct. This gives us 4 half-lives. So what does that mean? Instead of writing all these numbers, all I had to do is draw the arrow 4 times. So we're going to do this 4 times. So 12.5, remember we're working backwards. So instead of dividing by 2, because we're trying to figure out the original amount, we are now multiplying by 2. So 12.5 times 2 is 25.0. 25 times 2 is 50.0. 50 times 2 is 100.0. And last one, because remember it goes through 4 times, we have 200.0 grams. So what was in the original amount? 200 grams. Let's take a look at our next problem. If the half-life of iodine is 8.10 days, how long will it take a sample of 50 grams to decay to 6.25 grams? So again, we want to go ahead and list what we're given. So we have 50 as our initial. We have 6.25 as our final. Half-life is 8.10 days. It wants to know the total time. So again, let's go ahead and do the number line. We have our initial 50, and this time we are going to actually complete this number line so that we go down all the way to 6.25. 25, half of 25, 12.5, half of 12.5 is 6.25. So you can see that it went through the half-life 3 times, okay? So each half-life is 8.10 days. So this took 8.10 days, this took 8.10 days, and this took 8.10 days. So really you can do 8.10 times 3, right? Or if we just continue to add the half-life, 16.20 and 24.3, 24.30 days. That is the total time it took for this substance to go from 50 grams to 6.25 grams. What is the half-life of a 100-gram sample of nitrogen-16 that decays to 12.5 in 21.6 seconds? So again, we'll start with our initial, final, half-life, and total time. So we have a 100-gram sample that decays to 12.5 and took a total of 21.6 seconds. It wants to know the half-life. So again, if you're given the initial and the final amount, go ahead and just create your number line. It's the first thing you should do, especially if they give you the initial amount and final amount. So what I'm doing here is I just divided by 2, right? So we can see that it went through the half-life 3 times, right? So it's gone through it 3 times. So the total amount of time that it took to go from here all the way to here is 21.6 seconds. And again, how many times did it go through the half-life? 1, 2, 3. So how do we figure out just one half-life? Just one of these? If you said divide by 3, you are correct. You divide by 3, you get 7.2 seconds as your final answer. That right there is the half-life. Now let's take a look at the graph. Determine the half-life using the following graph. So what you do with this graph is you start here. This is your initial. And our initial for this one is 100%. Okay? So 100 divided by 2 is 50. So we're going to take it down to the 50 mark. And we want to go all the way across until we hit the curve on the graph. Okay? So again, 50 here. Go all the way across until you hit the curve on the graph. And then you're going to read the x-axis, so take it all the way down. And what does that say? That's 10 minutes. So the half-life is 10 minutes. Now, if I were to ask you the total time it took for 25% to decay, all you have to do is, again, just look at 25%, go all the way across until you hit the curve, and what does that say? That says 20 minutes, right? So I can also ask you how much remains after a certain time. So if I say how much remains after 40 minutes, you would look here, go up this time, And now you go across as straight as you can. And how much remains? That's probably right around anywhere between 5 to 7%.